Okay, I wanted to make a short video about an issue that really doesn't directly go to any of the homeworks, but it's an issue that comes up all throughout mathematics, and I notice high school students really struggle with this concept, and that's calculating percent increases and decreases. In Unit 5, it's going to be applied when we talk about growth and decay, but it's really just a broader concept than that. It's how do you calculate increase and decrease percentages? There's a lot of misconceptions around it. I see people do this the same wrong way every time, and I want to really draw attention to it, so I made a video just about that. Okay, so here's a situation. For example, let's say you've got a $40 dress and there's a 5% sales tax. Now we all know if I were to say calculate the tax, what would the tax be on that dress? You would do 40 times 5%, which most people know that's 0.05. Now this is going to give you the amount of tax, which in this case would be $2 if you calculate it. Okay, that's just the tax. Well, what if from the beginning, what if I had said, what would be the cost of the dress with tax? A lot of people would say, well, let's go calculate the tax amount, and then we're going to add 40 to that, and that's going to be $42. Sorry. That's going to be $42 with tax. Okay? But you don't have to do that. You can actually do this in one step. You can very quickly, very easily in one step multiply one number and find the amount of the dress with tax. And that would be to say $40 times 1.05. Okay? When you multiply by 1, what happens to a number? It doesn't change, right? That's because 1, if you think about it as a percentage, is 100%. So when we say we have a 5% tax, that means we're going to pay 100% of the cost of the dress plus another 5%. That's essentially what you did here. This was 5% of the cost, and this was 100% of the cost, for a total of 105% of the cost. Well, rather than calculating them individually and adding them, you can simply add the percentage. If I want to know the cost plus tax, I can just multiply by 1, the cost of the dress, 0.05, which is the cost of the tax. And by doing that, I get $42. Okay? There's a lot of examples of this, and sometimes the tax case, sometimes people are more understanding, but when we get into increases and decreases, for some reason people seem to have a hard time understanding it. So let's take this in a little bit different direction. So if I say I own a car that's worth $10,000, okay, and this car, let's say it loses 20% of its value. How much is that car worth now? A $10,000 car loses 20% of its value. Okay. Some people might look at this and immediately say, oh, well, it's going to be worth $8,000, because you kind of intuitively, the numbers are easy. You understand that. But think about what you're doing mathematically. Okay. If this car loses 20% of its value, again, a lot of people would say, well, let's calculate what is 20% of the value. They would do 10,000 times 0.2, because that's 20%. And that would give you the amount of value that you lost. But what I want to know is, what's the car worth now? So what you got to think about is this. If the car was worth $10,000 and it lost 20% of its value, you need to think about the fact that it is now worth 80% of the original value. This will not be stated in most problems, but this is what you need to think about. If something loses 20% of its value, then now it's only worth 80% of the original cost, or the original value. So that's what you need to multiply by. So to find the cost of the car, or the value of the car after it loses 20% of its value, you're actually going to multiply by 0.8, which would be $8,000. In this example, a town had a population of 12,000. It lost 6% of its population. Find the new population. So again, we have a starting amount, 12,000. Now I need to multiply this. I want to multiply by one thing, one number that's going to give me the new population. I don't want to calculate what 6% is and then subtract it from the original amount. You could do that, but I don't want to do that. I want to do it in one multiplication. And you're going to need to do this when we get to exponential functions. So instead of multiplying by 1, which would be 100%, I need to multiply by 6% less than 1. So in other words, if you have 1 minus 0.06, which is 6%. That is 94%. So if the town loses 6% of its population, what it actually has left is 94%. So what we're finding is, what is 94% of that original population? So I multiply by 0.94. And that comes out to 11,280. So again, when something is increasing by a percentage, you do 1 plus the rate of increase. If it's decreasing by a percentage, you do 1 minus the rate of decrease. Hopefully this helps you when you're calculating percent gains and losses, and it'll help you when we do the Unit 5 exponential functions.